Thou shalt put no other textbooks before thee in math class. I love math.
Using a graphing calculator to find the relative minimum and maximum and zeros of y equals 3x to the cube plus 15x squared minus 12x minus 60 if necessary round to the nearest hundredth. And the graph here says you do not need to graph it. This graph will not be great. So I'm going to pull up my Desmos. There it is. And I'm just going to type it in. Let's see if I can use my trick. 3x cubed plus 15x squared minus 12x minus 60. This is what my graph looks like. So not kind of what I wanted. So even if you did something like this, it's kind of big, right? So okay, I'm going to make a quick sketch because that just helps me. And this is what it looks like. And then relative minimum. The relative minimum would be here, relative minimum. And if you click on your graph, you get that number, 0.361, comma, negative 62.236. And this would be my relative maximum. So you can click on it, negative 0.69, comma, 37.79. And it says that one of the zeros. Zeros means where it crosses the x-axis. So that would be comma 2, comma 0. Negative 2, 0. And this last one, negative 5, 0. Let's look at our choices now. Looking for a relative minimum at 0.36. So this one matches. Relative max at negative. And zeros at 5, negative 5. So the x values are negative, that's y value. So x is negative 5, negative 2. 2, so that would be B. A they mix match them, so they said this was the relative what do they do? Oh, they switched the x's and y's. This one has only 2 of the zeros. There's 3. 1, 2, 3. Question number 5, multiple choice, factor completely. I guess that's wrong, you don't need to factor completely. Write the polynomial in standard form, then name the polynomial based on its degree and number of terms. So, just combine my terms. That gives you a negative, let's see, double check, looking at mine. That is a negative 11x, and this is a positive, so that would give you a negative 5x squared, negative 8x plus 2. And so not one of these. And then a minus and a plus 2, and this is a quadratic because of the highest degree, and it's a trinomial because that means 3. There's 1, 2, 3 terms.
Step number 2, your birthday. What's your birthday? Create your polynomial. So you need to write your birthday. You're going to create a polynomial, and if you need directions on the Google Slides how to make it an exponent degree, I'll show you guys. So my birthday is August 17th, 1983. Change it to numerical, 8/17, 1983. And basically these become the coefficients. Coefficients, or the numbers in front of the variable and degree. So I'm just going to write out the numbers 8, 1, 7, 1, 9, 8, 3. And you just need enough exponents, so x to the 5th, 4th, 3rd, 2nd. There's some more specific directions down here, 1 to 5. For example, if you do September 6, 1974, you can also make it 8 digits by putting zeros in there, and it'll tell you it's fine to have zeros, but you have to kind of tell us. And basically, you choose what to do with the positive and negative numbers. So how did I get that x to the 5th power? Let's say it's not there. Let's just say it says 5. Well, we might just put it over here. Let's say you want to exponent on that one, but you don't. Format text superscript for exponent. So format text and then superscript. Whoops, there it goes. Then you can type in the number, or I should have made a mistake. I should have just highlighted it. Format text superscript. Okay, so that's how you make an exponent using Google Slides or Google Documents. So we got your birthday, we got your polynomial. Number 3, we're gonna graph it. So go to Desmos or use your creativity. So if you're using like a jump rope, using spaghetti or candy on the floor, sidewalk chalk is a cool one. You're gonna insert your birthday. So let me go back over here. Copy and paste this. This is my birthday polynomial. Just put it right here. Okay. And now you're gonna go to Desmos and insert your birthday so you can get a graph. Okay, we're at Desmos, so I'm gonna paste mine in there. Now you're gonna look at this and it's gonna look kind of weird, right? So that's not an exponent, it reads it as 8x5. So what I need to do is open up this keyboard and I'm going to highlight the 5 and put a to the b power, which shows it's an exponent. So go ahead and do that for all of these. Okay, so here's my polynomial, and now if you look at it, it just looks like a big line, okay? So you could try to just press zoom out, and you'll notice I can zoom out forever, and it didn't really do anything. So what you're gonna have to do is use some critical thinking here. Let me go back to the original one around here, something like this. And I'm gonna have to change the window. So I think I'm gonna, you can press this wrench, make it a little darker. And I'm gonna have to play around with these numbers. So let's just say I wanted to go from negative 100 to positive 100. Let's see what happens if I just add a 0 in here. Let's see if it shows my graph. Nothing? Okay, so let's do the same thing with the y-axis. Let's go up to 70, see what happens. Nothing? How about 700? Nothing? 7,000? Okay, we're getting a little bit better. Let's add some zeros over here. How about a 0 there? And a 0 here. Okay, nothing much. Maybe we don't need to add zeros, let's see. So you're gonna have to play around, oh, we got something, and now it looks like a curve. You're gonna have to play around with this so that your graph, see, if you're using a tablet or your phone, it's a little bit easier to kind of move it around, but now I have a graph here. So this is a good thing. And let's see what our directions next. Toggle zoom and windows to find your graph. It should look like a roller coaster, which we have. And take a screenshot of your graph. Okay, so I'm on a Mac, and my Mac has, I think, Command Shift 4. Let's see what happens. And notice how my arrows turn to that. And now I have, let's see, and I'm just gonna press Control V to see what happens. Nope. There it is, it's right there. Well, look it up on the internet, how to find a screenshot. I can't do anything for you guys. Gotta do some work. And there's my graph. And then the end behavior, I already kind of filled out a template for you as x approaches positive infinity. This one, you're gonna have to erase one of those, either pluses or minuses based off your graph, okay?
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.